Hello, this is Mr. Yardley, and we're now on Lesson 2 of Chapter 8. If you're following along in your book, it's page 491, Prime and Composite Numbers. This is the second lesson in our fractions chapter, and today we are also not going to be focusing on fractions, but we are going to talk about prime and composite numbers. As we get into fractions, you're going to see how understanding multiples and factors of numbers and how prime and composite numbers, understanding those is very helpful in working with fractions. The factor of a number helps us determine whether a number is prime, composite, or neither. Blair is arranging cupcakes on a shelf. Find the factors of 18. Use arrays to find the factors. So here she has some arrays. Our first one is one row with 18 in each row. Our second one, we have two rows with 9 in each row. And then we have 3 rows with 6 in each row. So the factors are 1, 2, 3, 6, 9, and 18. Just in case you missed where I got those numbers from, it's 1 times 18, so I have my 1 and 18. 2 times 9, so I have my 2 and 9. And 3 and 6, so I have the 3 and 6 down here. So since 18 has more than 2 factors, we call it a composite number. Let's look down here at, there we go. Let's look down here at our definitions. These are very important to remember. A whole number with exactly 2 distinct factors, one in itself, is a prime number. So 2 is divisible by 1 and 2. 3 is divisible by 1 and 3. 2 does not divide into 3. 7 is only divisible by 1 and 7. There's no other numbers that divide into that. And 11 is only divisible by 1 and 11. A composite number is a whole number with more than 2 factors. So 4 is not only divisible by 1 and 4, but 2 times 2 also equals 4, and so that is a composite number. There's more than just 1 in the number that go into it. Now, 1 is kind of a interesting situation. We don't consider it either prime or composite because it only has 1 distinct factor. And if you look at the definition of a prime number, it has exactly 2 distinct factors, 1 in itself. So because 1 only has 1 factor, it is neither prime nor composite. Let's go ahead and move on to the next page. Oops. Okay. The question states that Sarah is at the park. She counts 73 kites. Write the factors of 73 on the kite and then tell whether it is prime or composite. The factors of 73 are, well, we know that 1 and 73 go into that. It's not an even number, so we know that 2, 4, 6, or 8 will not go into it. And we can add those numbers together. 7 plus 3 equals 10, which is not divisible by 3. And so we know that 3, 6, and 9 do not go into it. So since 73 has exactly 2 distinct factors, it is a prime number. It says to find the factors of 1, which is 1 times 1. Since 1 only has one distinct factor, it is neither prime nor composite. Okay, on these next questions, we're just going to go and see if they are prime or composite. I know that 5 is only divisible by 1 and 5. No other numbers go into it. So it would be prime. 15 is not only divisible by 1 and 15, but 3 times 5 also equals 15, so it has more than 2 factors. So it would be composite. (21) is divisible by 1 and 21, but it's also divisible by 7 and 3, so it would be composite. (31) is not divisible by any even numbers because it doesn't end in an even number. And it is not divisible by 3, so it would be a prime number. 26 is an even number, and so we know automatically that it's a composite number. The only even number that is prime is 2 itself. All other even numbers are automatically composite because they are all divisible by 2. And 61 is not divisible by 2. It's an odd number. And 6 plus 1 is 7, which is not divisible by 3. And so it is a prime number. That is the end of our lesson.